Thank you very much. Fantastic. So today we have two excellent speakers and a marvelous discussant. We have Andrés Rodríguez, Ben Steyn, and Yo-Yo Wu, I think. And so first we'll hear from Andrés Rodríguez. Andrés holds a PhD in economics from Stanford University and works as the Impact and Learning Manager at Stanford Impact Labs, an impact-oriented research funder. In his role, he leads the organization's efforts to conceptualize, document, and communicate the impact of Stanford Impact Labs' portfolio of investments. He also leads the internal learning agenda on using AI within the investments team. So without further ado, if you're ready, Andrés, the floor is now yours.
Thank you so much for that introduction. Hi, everybody. Very excited to be here. Okay. Great. I think this is working all right. So let's begin. So I'm very excited to share with you the learnings of an internal sprint that we did on how to evaluate AI's potential to aid one of our core functions within Stanford Impact Labs. I'm going to share more about the organization later on, but this was a sprint in which I collaborated with Michael Leddy and Julia Spencer. They work with me in Stanford Impact Labs. I think Michael is in the audience. Hello, Michael. So I'm very excited to share with you this because I actually, just as a preface, I feel very lucky that as an organization we took the chance on this learning sprint and asking this difficult question, devoting enough resources to actually make progress on it, which I think is not hard. I feel very lucky that we got to do that. So excited to tell you what we did. So let me begin with setting the stage, and I don't want to overclaim, but I do think AI has the potential to change a lot of what scientific institutions do, how they operate. It's clear in the space of writing papers for researchers doing different types of work, AI can dramatically shape what your day-to-day looks like. It also changes how funding looks like. And this is not a problem only of research funding, general funding as well, and any problem of like producing things to review, the other side of reviewing and selecting and allocating faces the same problem. I think AI can shift dramatically how this works. I think the funding part of the research ecosystem is already under pressure. How do we allocate resources is a hard question. The temptation of AI is speed. We could do this very fast. AI allows us to produce tools and things that an analysis that seem good superficially, and we could just do this very fast. But speed cannot come at the cost of good decisions. And I think that's what we're here to talk about. How do we even start thinking about whether AI can help us allocate funds or give us a sense of direction in which how to do that even? And this requires evaluation, not just anecdotes. And I love the introduction, Josie, because you set up a very good description of what an experiment and what a proper evaluation of whether this is possible looks like. And hopefully I can do justice with what we did at Stanford Impact Labs. So what we'll cover today, I'll tell you a bit more about Stanford Impact Labs, give you a quick TLDR of our main learnings, and then try to describe what we built, how we tested it, what the evidence showed, and what we think are the biggest takeaways for funders. So let me begin with Stanford Impact Labs. So we are an impact-focused research funder. We operate only within Stanford. So it's fair to say that our scope is relatively small. We fund mostly Stanford researchers in collaboration with external partners so that they conduct research that has the potential for social impact. You could say that that's kind of a niche, specific type of funding that we conduct. We do relatively, I would say, big award sizes for big projects, ranging from 250K to even large scale-up funding up to 3 million. We only receive 70 proposals per cycle. We know that is per cycle per year. That is probably on the small side for many funders. And this is a consequence of being an internal funder. So that's an important piece of context moving forward. And I think the important part to set the stage of what we do and what is going to be important for the evaluation is that in our status quo, how we normally review applications, it has two rounds. The first one we call a generalist review round, and the second one is based on subject matter experts and like very detailed due diligence. In the first round, where we do short generalist reviewers, that still uses academics and practitioners and our own Stanford Impact Lab staff to review proposals. We just don't do a very deep matching to make sure that full experts on a topic review each application. That's why we treat it as generalists, but the generalists are still expert academics from Stanford or sometimes outside, and practitioners also have experience in the world of practice and research put together. And then in this setup, we thought this first round where we shortlist applications and where in particularly we reduce the application pool by 80%. So we take the 70 proposals and we roughly try to select and shortlist the best 15 to move forward to a full due diligence. That's where we thought AI had potential. And this is important to clarify because today we're not going to talk about how AI could help the second round, or if even the idea of AI just selecting who to fund, we don't get that far. This is our shortlisting process, how we reduce by 80% our application pool and whether AI can help. And the reasons why AI can help, I think are not difficult to see. We have very limited information already. We evaluate mostly letters of interest, not even full proposals at this stage. It's a diverse pool of research projects. We are a generalist funder, so although we sit in this school, like in social sciences and humanities and sciences within Stanford, we actually receive proposals from engineering, School of Medicine, different topics. So we are a generalist, and that stretches out our capacity to evaluate different disciplines. And also we have a tight timeline. We want to make fast decisions. And the open question is, okay, do we think AI can help us in this first round of shortlisting? And we took a chance to evaluate. If you remember one thing, this is what I want you all to remember. I think we feel confident that AI can be a sophisticated screening partner. It can be efficient at finding or giving a signal about the good things. I don't think we're there yet that it can be a final judge. I think a big lesson from our evaluation is that AI can pick up promising projects on par with our status quo method of first screening projects via generalist reviewers and rankings based on how generalist reviewers, humans, score applications. This goes beyond other existing applications of AI for funding, which focus on screening out the weakest application to reduce the bottom of the pool. We go a bit further, and I think that is promising. And we can do it fast and reduce our costs of our status quo process. We do this, and this is a bit of kind of AI machine learning jargon. We do this with high recall, low precision, which means AI rarely misses what would be like top best quality projects, but it isn't good at only selecting top high quality projects. And I think that subtlety is important for how you make decisions going forward. And that's why kind of a benchmark for evaluation is important, because this feature of what I call high recall, low precision is also a feature of generalist human reviewers. So this is not something particular about it in our setting. The last two things that we learned, and I'm going to talk more about this, is speed and quality in our about whether AI can do a good job, is that AI allows us to do that extends just beyond the simple superficial capabilities of AI. And finally, safeguards and humans in the loops are not optional. There are risks. Even with the good things that AI can do, any funder should probably still design that around the risks and include humans in the key places where you need to include them to bear those risks appropriately. And I think this is just, risks, but also exciting because it allows you to think of how would you design a system in a world where AI can do a lot of the heavy lifting, if not. So now let me be more concrete about what we did. We did a multi-agent review pipeline and evaluated its performance. This is very important. This was a 4-month learning sprint. AI agents take letters of interest and do very specialized types of analysis. We backtested these AI systems based on historical applications. We created a sandbox environment using past applications to compare what would have been the outcomes of us making decisions aided by AI versus a status quo, which is making decisions based on generalist reviewers' rankings and how they score proposals. We used 4 years of past cycles to do this comparison. But we also did a parallel test and live deployed what AI can do for our 2025-2026 investment cycle this past year. So we also learned about doing our process as usual and where insights from an AI review process could help. So those are 2 types of learnings that I'm going to share today. In our 2 pipelines for analysis, I think the approach that we took was we first developed AI to analyze a proposal. Every single proposal needs analysis, and AI can do this. There's research, summarization. There's many things that you can do about this, and I don't think it's crazy to see why AI could do this. The other problem is ranking. How do you even approach the problem of ranking proposals to help you select or shortlist proposals, in our case? And we build these 2 things, and they're not always... They don't always go hand in hand. And this was an important lesson of our designing. I could go into detail about what each of these pipelines and individual analysis and like agentic workflows look like. Something that I think is a key design lesson is that in our usual process, we have a rubric. Our generalist reviewers grade proposals against a rubric. We asked AI to do that as well. That process was not very good to rank proposals. So we came up with a more sophisticated tournament version where AI had to compare proposals, and we used an algorithm on top of that comparison to generate a ranking. So AI had the simpler task of seeing 2 proposals, deciding which one was better, and an algorithm handled the ranking. So this was kind of I would say kind of an innovation to help us make decisions. But it also kind of separates the process of how a rank can be generated from how an individual analysis of each proposal, where you have literature reviews, when you have practitioner landscapes and many other things. I will not explain in detail what this full agentic system looks like because that would take me a lot of time. But visually, this is what we did. And this is kind of, it has a lot of things: literature review, academic analysis, practitioner analysis, giving us that we're an impact-oriented funder. We wanted to keep these 2 perspectives that are very important for how we conceive the evaluation of an application. And we used AI to help with this. We scored against the rubric, as I told you, but the important thing is like the heavy lifting of the ranking, how we ranked the proposal, was done by kind of a tournament, comparing a lot of proposals and taking advantage of the fact that we can use compute to actually compare many proposals against each other. That is not possible with human reviewers or with generalist reviewers. but it is possible with AI and computation. So let me get to the crux of the evaluation. And then probably you have a lot of questions about what goes in the background of the AI system, but for now, believe me that we built a sophisticated AI system that evaluated and ranked applications. So we are able with AI to generate a rank of our 70 applications in a cycle and use that ranking to make decisions. What do we do with it? So first we evaluate it. And I think this is very important that we're talking about evaluation, not about how we plan to use the system. This is only to learn whether we can trust it or not. We used 209 past applications across our funding stages and cohorts. And we created a sandbox environment.
You're instructed to the gravity of her talent.
We created a sandbox environment where we simulated our round one shortlisting. So this is where we compared how AI ranked proposals and how our generalists, because these are past proposals, how our generalist reviewers scored proposals and also helped us rank. And we compared the decisions that we would have done using these two rankings. And in particularly what we care is how much signal of good quality projects are in those two rankings. And we're trying to horse race them and compare them. And judging what quality is, this is very, very hard. And this is a big lesson of an evaluation. Talking about what quality selection is a complex problem. Our best marker of quality is what we funded. Do the rankings from AI or from our generalist review rankings include funded proposals? We also have shortlisting, which ones we actually shortlisted. So that is kind of another outcome, but that is a kind of analyzing that as the best marker of quality or as a marker of quality is kind of complex. So we try to focus on, do the rankings include the proposals that we funded? And importantly, we funded them because they went through a further round of due diligence. And that's why we feel confident that they are the best in projects in our pool. So here's what we found. And on funding, which as I said is our best marker of quality, we found the AI is very much on par with generalist reviewers. When we compare the rankings that we obtained with AI and the rankings that we obtained with generalist reviewers, and we just count if they are missing proposals that we funded across these 4 years, we found that they miss roughly the same number of funded proposals. It changes how we shortlist, so this is very important. We shortlist different proposals, but the top ones are different. And this is why one of the lessons was, I think AI can have high recall. It does not miss the best projects, but it changes the application pool, the shortlisted pool. And this creates risks. And depending on your setting, this might be important. In our parallel test, the AI output also improved things. And it simply was just a kind of a better starting point. And in the interest of time, I'm going to skip some of these details. But besides us testing the quality on a historical application pool, which is kind of what I was showing you here, also we saw value in our process of using AI. And not only because the rankings were good, but because it helped us make better decisions and discuss why certain proposals were ranked high and low. And it simply was a better starting point to judge what quality proposal is. Plus, it was fast. It was relatively cheap. We reduced our costs, just comparing what would cost to run this AI model, $200 versus what we would spend on generalist reviewers. It was an order of magnitude difference. An important fact, we asked our 2025-26 applicants if they consented for us using AI for analysis and review. They all did. Let me just wrap up with the big lessons and the takeaways that we have. First of all, how we evaluated AI is not how we plan to use it. We evaluated and we simulated AI selections and shortlists just to know whether we could trust it or not. I think we found that AI can support our core function decision, which is identifying these top projects, but it's not a magic bullet. It can detect high quality proposals, but it not only selects high quality, but we can do this fast, consistently, and relatively cheap. We have to build systems around AI and not simply automate away. We are not just trying to take away the role of field staff and other generalists reviewing proposals, but now we are able to rethink how the evaluation system should work around it. And if AI can do a heavy lifting of initially screen and review and research and rank proposals, where we're going now is trying to allocate human effort better to where it matters the most, to help us. Not all applications should be read by the same number of reviewer eyes with the same level of rigor. Maybe AI can help us do a first screen, and we can direct human effort to where marginal decisions are more important. And this also includes targeted safeguards. But AI limitations are real. They're not the perfect literature reviews. They're not the best at identifying innovation. Yet still we can use it to rank and help us aid in the selection. And I think some people get in the way of thinking like, oh, the literature reviews that AI or are not perfect. It's like, yes, but you don't need perfect to help you in making decisions. In the end, our lessons are just one data point. We are a specific type of funder, and we are willing to take certain risks. And I think it's important that other organizations build their own tests to understand the risks that they're willing to take. We need to keep wrestling with the harder problems, which are AI use by applicants. AI is stochastic. We might face some cognitive overloading, and just the staff doing all this thing might not engage with proposals as much. And these are all just harder problems that we don't fully touch upon in our analysis, but they are definitely in our eyesight. I went very fast through a lot of content, so very eager to hear questions, comments. Reach out to me via email, or happy to engage later today. Thank you so much.
We're then going to move on. Thank you, Tom. We're now going to move on to Ben Steyn. By day, Ben is a UK science policy civil servant, currently founding co-head of the DSIT UKRI Metascience Unit. He is a former founding member of the Advanced Research and Invention Agency as well, that's ARIA. By night, Ben is a postdoc academic with research interests in technological ethics, philosophy of AI, political philosophy, metascience, philosophy of science, and political science. So, Ben, the floor is yours.
Thanks, Josie. Yeah, let's just get this up. I won't be able to see questions, so just like Tom or Josie come in if there are questions. So yeah, quick slide on who we are. The Metascience Unit, we're across DSIT and UKRI, as Josie said. We sort of fund a lot of meta-science research through grants and contracts, fellowships and things like that, trying to build the field. And we also do the in-house experiments, the sorts of things that you guys are doing with RoRI. We have a sort of in-house function in UKRI doing these sorts of things. So peer review. So I think, you know, just from first principles here, what is the objective of peer review? Well, we're trying to maximize research quality, speed, and the reliability of our processes. I.e., you know, do they go out on time? Do they fund to the dates they said they would, etc., while also minimizing the burdens on the various stakeholders involved. That seems to be the broad objective function. And the sort of old policy paradigm that we've all grown up in is that you have human review of human applications, and because human review is all you have, you sort of assume by default that that process gives reliable-ish, although we know coarse-grained assessments of research quality, very subjective, very noisy, etc., but sort of broadly okay. And the sort of policy issue has been, you know, that review process is what it is. Can we make it quicker? Can we make it more efficient? So in the UK, we had a review of UKRI's processes called the Tickell review. You know, the conclusion is basically efficiency is the problem. And you know, the quality of review is just assumed because, you know, it's humans reviewing humans. That's all you have. The new paradigm we're in is, I think, one where, you know, you have humans and AI doing peer review potentially of human and AI applications. And, you know, applying is a lot cheaper. It's basically now a cost of zero to write a grant application. The cognitive process of reviewing is much harder. There used to be this long tail of poorly written applications that you could just use as a heuristic, that, you know, as a reviewer, it must not be that good because they're sort of not conforming to the norms of how the academic community writes. That's no longer the case. And sort of as in the last talk, the point was made, you know, efficiency comes cheap now. Like, you know, if we want efficiency, we can have it, but ensuring that quality is much harder. So this is my new sort of compass / policy framing device that I think sort of sums it up. We have applications that could be on a sort of spectrum of human to AI, and then you have reviewing of those applications that can be on a spectrum of human to AI. And the policy question is, where should we as funders be in this matrix? Well, we'll get into arguments for being in different points here. But first, we should just see that this is basically an analogous problem at all stages of the research process, all parts of the research system. So we're talking here about funding, but then you have stage 2 within the research process itself. You know, that's a little picture there of my PhD supervisor, Robert Northcott. When I had some research that I'd done, I would go to him for some critique. Now I just go to Claude. So, you know, there's questions within research about AI doing the doing, AI doing the validation. Then at publication stage, again, you know, similar problems that we have as funders, AI slop, AI as a fight fire with fire response to that slop. And then at the sort of post hoc evaluation stage, you know, funders, you know, we think about doing program evaluation. Can we automate that sort of thing? But also, you know, things like academic recruitment, you know, things that require us to look back at a portfolio of research in some form and measure it. That again could be AI driven or not. And similarly, how that portfolio is curated in some sense, it could be humans getting together and submitting something like in the UKREF, or it could be, as in the last talk, an AI agent that looks back through a person's history by like doing sort of online search about them. So it's sort of all the same problem, and crucially, these layers of the research system all interact with each other. You know, like the funding peer reviewer is cognizant of what the publishing world is saying in that field at that time, etc. And so the sort of grand question is, you know, where are we going to end up? Like, what's the steady state here? Like, you know, where are the humans in the loop? Is the equilibrium going to be the blue line through AI on every plane? Is it going to be some sort of messy line? We don't know. But it's important to like think about the whole system because, you know, it's a trope, human in the loop. Maybe the human is in some stage of this wider loop, not necessarily in funding. So like this problem here, like where should we be? Like, this isn't like one research project, is it? It's sort of, it's what a whole field needs to exist to answer. And the Metascience Unit, like, you know, previously has funded lots of meta science in lots of sort of areas of research policy, you know, trying to build the evidence, but we're trying to think now from this year onwards about, different axes of this problem, trying to better understand science systems in an AI age, basically. So, it's at the top there, understanding automated reviewing potential and doing sort of similar things to what we heard Andrés talk about. But then it's also thinking about funding process reform in a sort of human sense, where you think humans are important, building this subfield of the science of AI for science, understand how AI is changing research itself. We're launching a big survey. We've got fellowships and grant pools there. And then making big investments in scientometrics, new measures of research quality that you could apply at the level of a paper or a grant proposal, potentially as a way of sifting AI slop, but other uses too. So this is the field, I think, like going forward. This is for me the core of meta science going forward, or at least like one big strand of it. So collapsing back down to like the dimension that we care about most, like grant peer review. I guess I don't have a huge amount of time, but over the last year or two, I've sort of tried to collect or hoard arguments for being in each of these quadrants. So maybe we can just think about some of these arguments. As I said, this is a conceptual talk. I'm not presenting any empirical data here on what we've done. I thought Andrés did a great job with that. So I'm more just, this is me as a philosopher, less me as a meta scientist. So I hope that's okay. So why do we want to be in the human box? Well, arguably AI can't either write or review or detect not truly novel work or truly rigorous work. And maybe there's this sort of doom loop where, over time, the novel and rigorous researchers leave because they're not being particularly selected for. That might be a sort of family of worries there. Maybe peer review has this pedagogical function. It's more than just selection. It's like that there's some learning going on there that you're missing out on. Maybe there is a topic bias. Maybe there's an AI to AI homophily. The AI likes the AI, not necessarily the good stuff. There's arguments like that. Why would you be on the AI to AI side though? Well, there's clearly an efficiency benefit on the face of it. As we've said, it lowers the cost of writing applications, lowers the cost of reviewing. You could see this as a problem where you open a new lane on the motorway and suddenly more cars go to that motorway and the traffic doesn't get any better. Maybe AI lowers the cost of applications and you just get floods of more applications and it doesn't become more efficient. But if you're using AI to combat that, then in the long run, there's this sort of grand automated process that maybe is more efficient. That would be sort of where it ends up. There is this brute fact that human is not an enforceable position for funders anymore. We can't reliably and certainly surveil the use of AI either in review or in submission. So you have to then default to allowing AI and therefore using it yourself. You could be just an all-out accelerationist and think that the AIs are smarter and should just be left to do that loop. You could also point out that there's all these problems with traditional peer review that we all know about, and maybe AI is less biased in many ways. As funders, we all know that sometimes you get peer reviewers and they're looking for different things than you as the funder were looking for, and the AI arguably has that problem less. You can control them. They will look at the criteria that you tell them, so that's something. And you get these arguments that it levels the playing field for many applicants, non-native speakers, those with learning disabilities, etc. And maybe a sort of rebuttal to the idea that AI might downweight truly novel science. Well, maybe we don't actually need it. Like maybe we can get pretty far with just our current scientific paradigms if we just sort of allow automated science to let fly. So I think those two sides are sort of like the sort of most popular camps. I think these ones are more interesting. Like I would really like to see a sort of more robust defense of these positions, but like this is all I've got so far. So why would I think that reviewing could be done by AI, that the applicants should always be human? Well, maybe it's that I think AI is this diligent but uninspired reviewer. They can recognize the greatness of my philosophy. They couldn't write it themselves. Maybe that's the sort of argument there. You may also think that while humans are sort of individual and great and better scientists, the reviewing of them could be done most consistently with AI. So sort of picking and choosing certain arguments from the other side. I think this is also perhaps the most radical position to be in. Why have applications come from AI and reviewed exclusively by humans? Well, you know, maybe the thought is that like AI will just function as a sort of shop window for us as funders. So we as funders, we know what we want. AI agents then go out and sort of mediate what was a funding process, and sort of a researcher doesn't anymore submit an application. They're just sort of found, they're headhunted by some sort of combination of agents. They're sort of passively involved in some sort of grant winning activity. So that's one option. I guess there's this more radical idea that maybe in some future world where AI is writing papers and credited with doing so, you get the death of authorship, and maybe the only socially valuable task left for the human scientists is to be involved in peer review processes, and then that would be the credited thing. And that would be the sort of way the system is structured. So, pie in the sky stuff, but, So, I myself sort of trying to be a hard empiricist about it. I'm trying to sort of like, build the evidence and not just sort of default to the easy options of human or AI, depending on your sort of persuasion. And I think sort of, while being agnostic, we've also sort of got to act now in the world. If you read James Wilson and Geraint Rees's recent Nature commentary about this, I think he's used a lot of your data to show that application numbers are climbing, peer review processes are really struggling. We need to do something, and so I sort of align myself in sort of center of this map. I think we need a combination of high friction artisanal approaches, human approaches where we think humans have some unique strategic context, or expertise that is better than the generalist, while also exploring all the sort of efficient ways of doing both human and AI sifting of proposals in the sort of large grant schemes that UKRI typically runs. And within that then, so going back to my big sort of grand problem, if we just look at review, funding process reform, we're interested in distributed peer review, desk rejection, automated reviewing assistance. These are sort of ways of dealing with the volume problem. But I think also it's about that artisanal human stuff and using humans judiciously. That's about all I've got. Sorry, no data to share. But we are doing similar things to Stanford there, but we just don't have the results yet.
That's fantastic. Thank you very much, Ben. That was, again, lots of food for thought there for everybody.